All right. We're looking right now. We are looking right now at Algebra 2 Part 1, Counting Outcomes class notes. I know you've got 3 different worksheets in front of you, so I want you to pull this one out. This is the one you should be looking at. Okay? So, all about probability. So this should say, whether we are rolling a couple of dice or deciding what we want on a sandwich, there is always a way to calculate the number of possible options or outcomes that exist. We can make a tree diagram to find the number of possible outcomes for the following situation. So this is kind of similar to what we did for the warm-up. But we're going to kind of do a tree diagram for it instead of making like the little squares and figuring out where things go, okay? There are 2 types of cones, cake and waffle, and 3 flavors of ice cream, okay? So I'm going to make C for cake cone, W for waffle cone. And now I'm hungry. You guys too? I want some ice cream. Yeah.
I feel like I'd be more academically able to succeed if I was able to do it.
Go sit where you need to sit. Okay, so we've got 3 flavors. I'm just going to call them 1, 2, and 3, all right? So we can have 1, 2, 3, flavor 1, 2, and 3, and flavor 1, 2, and 3. Everybody okay with how I got those? Cake cone can have 3 different options. Waffle cone, 3 different options. How many options altogether? 6. 6 possible outcomes. Okay, we're going to pick a number 1 through 4, and then we're going to flip a coin. Okay, so I could pick number 1, I could pick number 2, I could pick number 3, or I could pick number 4, correct? And then when you flip a coin, what are the 2 possibilities that you could get when you flip that coin? Heads or tails? So we've got a heads, a tails, heads, a tails, heads, a tails, and a heads and a tails. Okay. So I've got 1, 2, 3, 4, 5, 6, 7, 8 options. 8 possible outcomes. How are we feeling about this? Okay, good. All right. We're looking at the diagrams above. We might notice something. We're supposed to be discovering this fundamental counting principle. Okay? If one event occurs in M number, so that's just could be any possibility, so we're using M as like a variable, like any possible number of ways, and another event occurs in N number of ways, then the first event followed by the second event occurs in Mn ways, where we're doing M times N. So let's go back and look at these. I've got 2 cones and 3 flavors. What's 2 times 3? Is that how many options we came up with? This has 4 possibilities, and then the coin could be flipped over and have 2 possibilities. Okay, what's 4 times 2? 8. Okay, is this starting to make sense? Okay. So, if I have 3 pairs of shorts, 5 shirts, and 2 hats, how many possibilities are there?
30.
Because we went 3 times 5 times 2, giving me 30 possible outfits.
Good job, Josh.
Okay. Is it starting to make a little sense? Okay. You could do it. Like, I've done it before when I'm like, I don't understand this. And I've been like, okay, here's a pair of shorts. Here's a pair of shorts. That's my drawing of shorts. Here's a pair of shorts. They're horrible. And then, like, here's a shirt. Right? And I've gone through it. Well, that takes a really long time to think about all those different options. Instead, if we know we're just multiplying them together, that gives us our number of outfits. Math is all about shortcuts, so you have less to do. That's the whole point. All right, we've got a spinner. It's got red, blue, yellow, and green. How many different options does it have?
4.
4. Don't forget the green. Okay, so 4 options, and then a coin flip. Do we remember how many different options does a coin flip have? 2. So we end up with 8 different options. Good. Okay. A 6-sided die is rolled, and a card is picked from a standard deck of cards. So this, you have to know some prior information here.
312.
Okay? You have to know some prior information. It says a 6-sided die. So right away we know the die could land on one of 6 sides. We good with that? So that's 6 options. Now here is the prior information you have to know. How many cards are in a deck of cards? 52, okay? 52 different cards that you could pick out of it, okay? So that's how we did 6 times 52, giving us 312 different possibilities.
Why do you know that's by heart?
Okay. So, this one confused me for a second and I had to look at it again. A coin is flipped 6 times. So how many different sides of a coin are there? 2. But I'm doing it 6 times, right? So we just get 12. Christian? Christian? Christian?
Chris.
I woke up out of her.
Okay, you write this down?
In my head.
No, because you're not even on the right paper.
Man, look.
Come on, you
I'm
can.
stressed.
I know you're stressed, but you can ace this. I know you can. But you gotta write down what I'm doing, okay? You can do this. Good. That's why I moved you up front. All right.
How hard is it, Mom?
All right. So,
Lid.
we're gonna look. 3 regular dice rolled. Hey. Shh. Focus. Yes.
Got some lead.
Here's a pencil.
So 6
Okay.
times 3?
Right? There's 3 dice. And there's 6 possibilities, right? So it is 18. Okay.
Can't even see.
I can zoom in.
My boy, you ain't trying.
Bro, you got on glasses. Bro.
All right. We're going to talk about a Michigan license plate. All the different possibilities for a Michigan license plate.
You know about the virus in Washington?
Bro.
Okay. But we got to do this right now. We can talk about that in a minute. We've got 3 papers in front of us, guys. I want to get through this. Okay. Jamal, I need you to put that phone away and not pick it up again. I know you're addicted, but like focus. Okay. So, the license plate consists of 3 letters and 4 digits, 4 numbers. Okay? How many, in this case, we're just saying that this is what it's going to have to give us. How many possibilities are there? So that's the ultimate question, and we're going to get that at the end. How many letters exist that we can use on a license plate? How many letters are in the alphabet?
Oh, wait. Oh.
It's like 21.
28.
It's like 26.
26! There's 26 letters in the alphabet.
So
26 letters in the alphabet. Okay, so I can choose any 3 letters. It doesn't say anything about, doesn't say that they can't repeat or anything, right? So I can use them as many times as I want. So my first space, I can choose 26 letters, right? My second space on my license plate, I can choose 26 letters. And my third spot on my license plate, okay, so Shasan, it's like letter, 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 number, number, number. So this can be a letter, number, number, number. You with me? Okay. So I've got 26 times 26 times 26, or if we have 26 times each other 3 times, this is the same thing as 26 to the 3rd power, right? You know, mathematicians are all about laziness. The least amount of writing you can do. So instead of going 26 times 26 times 26, 26 with a little 3 up top, quicker. All right, how many digits exist? How many numbers can I use? I can use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? You can't use 2-digit numbers in one spot, so it's got to be just those 10. Okay? So if we've got a number, you got to include 0. 0 through 9. Right? So 1 through 9 is 9, and then you got the 0, gives me 10. Okay, so for number, we've got 1, 2, 3, 4 spots to do numbers. So we go 1, 2, 3, 4, or 10 to the 4th. Beautiful.
Woohoo.
Okay. So, let's take out our calculator. Unless you can do it in your head. What's 26 times 26 times 26? Or 26 to the 3rd power? You want to give me a guess, Josh? It's your favorite thing to do.
I wouldn't even know.
I have a general area.
Okay, give me a general area.
176.
I said, watch, I guessed it, but I bet it's right.
76.
Whoa. Oh, that's a lot of numbers.
Okay,
I was gonna say.
what's 10 times 10 times 10 times 10?
100,000.
Oh, wait, I was supposed to.
It's 10,000.
You said 100. I said 576.
Okay, so how am I going to find my total possibilities? Not add, but multiply. It's going to be huge, right? So you can also go 26 to the 3rd power times 10 to the 4th, and then you have less stuff to type in your calculator, right? But you get 1,760,000.
That's a fat number.
Yeah, that's so many possibilities. Mm-hmm. Yep. Okay. I want to do some more like this. So let's go to the one that says basic counting principle. It says basic counting principle. And we're going to do more like that license plate thing. I want you to have lots of practice before I let you do it on your own so you really get it. Okay. So, a computer password is to consist of two lowercase letters followed by 4 digits. How many possible passwords are there? Okay.
It's more than
Sydney,
10,000.
middle table right there, but grab those 3 papers, okay? Yep. Okay. How many letters are in the alphabet again?
26.
Okay, that's an important thing to know because we're going to use it a lot. Okay, it doesn't say it says I can repeat it, so I could have like an M and then an M, right? So I need 26 more letters are possible. The 10, because I can go 0 through 9, right? 10, 10, 10, and 10. And what am I going to do to all of those to come up with an answer? That's why you need a calculator, right?
7.
Okay. So on the other page, we had 3 letters and 4 numbers. And here we have 2 letters and 4 numbers. So it's going to be a little bit less. I get 6,760,000. Which is why these passwords that are like this are hard to crack, right? Because you have so many possibilities. You can't just guess them.
That's just too much.
Okay. All right. Now, let's read this next one. It says, how many passwords are there if you cannot repeat any letters or numbers?
26 and
Okay, so the first one's 26, but what's the next one? 25, right? Because you used one letter and you can't repeat it. So you can't have like M and N.
so then you go 10
Why didn't we do that on the top?
Because the top ones didn't say that. It can repeat.
Wouldn't it be 9?
Okay, so we have 10 possibilities for the first one. But we can't repeat the numbers. So the second one has, and the next one has, and the last one has. Good.
Oh.
Does that make sense? Because you used that number, so you can't use it again. Okay. So I'm going to end up with, I get 3,276,000.
Wow.
It takes me, it's so hard for me to say that. I get mixed up with this stuff, like saying the letters out loud. I don't know why. I told somebody once that my couch that I bought cost me $10,000. No, it cost me $1,000. Who buys a couch for $10,000?
You ain't better.
No.
Trying to sit on that alpaca.
Right, like, no, it's not made of gold or platinum. All right. Let's do the next one. Okay, you ready? How many passwords are there if the first letter must be a vowel and repetition of letters is not permitted? Okay, so first we have to talk about what vowels are. What are vowels?
A-E-I-O-U.
And sometimes Y. Okay, so A-E-I-O-U and sometimes Y. So how many is that?
6.
So there are 6 possibilities for the first one because it's got to be a vowel. These are like, if you got this on a test and you're like, I don't know what vowels were, I would tell you. Okay? All right. How many other letters are there? Because we can't repeat those vowels. Okay, so we have 6 vowels. We can't repeat any of them. So what other numbers can I use? 20.
What? How could you? Oh, this
Because you can't
Because I can't use vowels, so I can't repeat.
Oh, subtract about 26 minus 65. I'm gonna act like
It's only there's a number of letters.
You know what? I don't agree. I think I have the wrong answer here. I think it should be 25. I think I'm wrong.
What?
Okay, so this is why I think I'm wrong. Shh. I think it's 20. I think you guys were right. I think you guys were right. Because it doesn't say that I can't have a vowel in the next one. It's just that vowel. So it's just one less that I can. I think you're good. I think it's good.
So it is 25.
Okay. The first number cannot be a 0. So that means how many possibilities are there?
9, 8, 7.
The second number cannot be the first number cannot be a 0 and there can be no repetitions. So what is the possibilities for the next one?
8.
So it could be 0 though, couldn't it, for the next one? But I just can't be this number. So I think it's 9. Yeah?
But wouldn't it be 8 because you can't use that one number?
But I can use 0, but I couldn't use the 0 for the first one.
Oh.
So I could, like, say it's 1, I can use 0, 2, 3, 4, 5, 6, 7, 8, 9. And it's like, makes my brain explode. Okay. Now we can't repeat. So the next one has to be
8.
8, and the next one has to be
8 again.
not 8 again, but
7.
7, right? Because I've used those numbers. Because by the time I've had 7, I've used 3 numbers, so I can't repeat any numbers.
Well, how you get 8?
Okay, yeah, okay.
Explain the 8 and 7.
Okay. So, hold on. Jason asked me to explain the 9s, and then I'll explain the 8 and 7. Okay. All right. This first one, it says it can be any number but 0. So I had to have it be 9. Okay? The next one says I can't repeat, but I could use 0 for this one. So that's why it's 9. Yeah. So like if I used 1 here, I can use 0, 2, 3, 4, 5, 6, 7, 8, 9. Okay? This next one, I've used 2 numbers. So I have to so I have 10 possibilities, but I've used 2 numbers, so now I only have 8 possible numbers I can use.
But how is the next one 7?
So the next one, I've used 3 numbers. So out of my 10 numbers that I could use, I've used 3, so I only have 7 more left. It's kind of Manny or not really? You're all right? You'll get it eventually? Okay. Now we're just going to multiply these. 6 times 25 times 9 times 9 times 8 times 7 gives me 680,400 possibilities. Okay. All right. We're going to move on. I did not write this, by the way. My names were better. I made up the warm-up. Okay, so Bob, Sue, Larry, Sally, and Fred, apparently it's 1950, are waiting in line to buy concert tickets. In how many different ways can they stand in line? So, there's 5 slots, right? How many possibilities are there for the first one? 5. Okay, now I've used 1 person, so how many possibilities are for the second one?
4.
Okay, so I've used 2 people. How many possibilities are for the next one?
2.
5, 4,
2.
2, 1. Now I'm just going to multiply them. 5 times 4 times 3 times 2 times 1 is, Josh, say it again.
121.
120.
It's 120.
It's just 120, isn't it?
Yeah,
Wait. Oh, because it's time 1.
It's times 1, not plus 1.
I added it.
Okay. All right. Now, how many ways can they stand in line if Larry insists on being in the middle?
Before 3. Wait.
So it would be 4. Go ahead.
4, 3, 2.
2.
It would still be 1, right?
No, it would be no 1 because he has the 1.
So it'd be
But you could have
4,
2
3,
ones.
2, 5.
How can you have
Okay.
Because it don't say you can't repeat, right?
You can't repeat. You can't put people in a line. But we can stand up and do
How's
this.
it only 1? How's it 2 1s then? How can
All right,
it
all
be
right.
1?
You 4, come up here. Come on, quick.
Without.
Okay, come on. Okay. I'm Larry. I'm insisting on being in the middle. Okay. So you guys all stand in Kayla in a line like this. So Josh, go behind Kayla. Yes, do it. Go behind Josh. Go behind. Okay. Everybody's ready. All right. So do you see how there's 4 possibilities here?
Yeah.
Okay, now Kayla's gonna stay there. Now the 3 of you guys move this way. All 3. So it chose 1 person to be in that spot, right? So there's 4 possibilities, 1 was taken away. So now we have 3, right? Now Josh is gonna stay here. You 2 go over here on this side. Now, do we see in this spot we've got 2 possibilities? 1 of them's chosen. So how many people is left? So 1. So there's only 1 person for the last spot. Does that make sense? Okay. That's why there's 2 1s. Because I didn't move, but the last one only has 1 spot.
6 people. Come here.
Okay. So now we're going to multiply. 4 times 3 times 1 times 2 times 1. 4 times 3 is 12. 24. Okay. All right. How many ways can they stand in line if Sue must be first and Bob must be last?
1, 3, 5.
So we've got 1.
3, 2, 1.
1, 5, 4, 3.
Okay. So if we've taken away Sue and Bob, how many people are left over?
3.
3. So it's 1 because Sue's not moving.
3, 2, 1.
3, 2, 1.
So it's just 6.
It's just 6.
Can I get some water real quick?
No. Okay. So we're going to turn it over and we're going to do the back and then you guys can do your homework. Okay.
Gavin, you're late.
He was taking a test. That's homework.
I
for today.
do.
Okay. So this whole thing, 17 through 20, I know it says classwork and then it says homework, but it's classwork. We're going to do it right now. 17 through 20, an identification code is to consist of 2 letters followed by 4 digits. So we got letter, letter, number, 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 number. Okay? 2 letters,
Why is it a D?
4 number, digit instead of N. Okay. Repetition is permitted. So that means there are, okay, how many letters are possible for the first one?
26.
How many letters are possibility for the next one?
26.
26, because you can repeat.
Yeah. Oh, wait for a minute.
Okay.
Yeah.
How many numbers are possible?
9.
10. Because you can have 0. I know it's real confusing with the 0. How many numbers are possible for the next one? 10, 10, and 10. Okay. Because it says you are allowed to repeat.
This is 6 million something. 6,760,000.
No, John. Yeah, it is.
Yeah, you already did it.
6,760,000.
No.
That's not it.
6,760,000. Okay. So, 18 says the first letter must be A, B, C, or D, and repetition is not permitted. Okay, so what is the possible, if the first letter has to be A, B, C, or D, how many possibilities are there?
4.
4.
4.
Okay.
Yeah.
The next one has to be
25.
25, because we've taken away one letter, but we can have anything else.
So it's 1 million.
Okay? And then it doesn't say anything about the letters, so I know I have 4 10s in a row. Okay? So then you just are multiplying this, so we go 4 times 25 times 1. Oops, I did plus. That's not going to be anything. 4 times 25 times 1, 2, 3, 4. I get 1 million. Yeah. Okay. Repetition of numbers is permitted, but repetition of letters is not permitted. So my first letter, how many possibilities do I have? 26. My second, 25. Numbers is permitted, so they should all be 10. So 26 times 25 times 1, 2, 3, 4. I get, that's not what I get. I get 6,500,000. Okay. For number 20, repetition is not permitted. So we should have 26, right? And then, what comes next? No, wait, we got 2 letters. So 26, and then 25, and then 10, and then 9, 8, 7.
3,276,000.
I get, yeah, 3,276,000. Okay. Do we want to do the next 4, or do we want to look at our homework? Homework? Okay, let's look at our homework.
You want me to tell you the truth? I ain't never did a note.
Still today? Yeah, I know. Okay. So, this whole thing is supposed to be fun. You're supposed to, like, whatever number, excuse me, whatever number you get here, you're supposed to go down here and find the coded answer. And so the question is, why was Jesse James in the hospital? So you're supposed to figure it out at the bottom. Okay? So, you're going to find the answer in the code at the bottom of the page. Write the letter of the problems above the answer each time it appears. So I'm just going to do number 1 with you on the front and the back. Okay? And then you guys can do the rest. All right, so here it says, if you spin each of these spinners once, how many possible outcomes are there? So how many possible outcomes are there for the... There's 3 possibilities for the first spinner, right? How many possibilities for the second spinner?
4.
So 3 times 4 is?
12.
So then I go down here, and wherever there's a 12, I put the letter I.
Oh, I know that.
I knew what you meant. It's just not, yeah. Just,
There's only one eye.
okay, yep. All right, let's look at the back. Same thing, it's like a coded thing. Number 1, whatever number you find the letter over here and then put it at the bottom, okay? In how many ways can you arrange 6 things? How many ways can you arrange 6 things? So, you kind of think of it as a possibility like this. 1, 2, 3, 4, 5, 6, right? So you have 6 ways, 6 possibilities. 5, 4, 3, 2, 1. So you go 6 times 5 times 4 times 3 times 2 times 1. Get 720. So over here, 720 is S. So you go down here wherever you see 1, you're going to put S. And it's going to answer, why couldn't the church steeple keep a secret? Okay? All right. You guys good for doing the rest of these on your own? Ask me questions if you need it. All right, I'm pushing stop on here. Riley, will you hit the lights